Hello, good morning students, and welcome back once again to another video for the class 10 physics light chapter. And in the previous video we studied about the 6 cases of the concave mirror and how their images are formed. If you remember, we studied that if the object gets closer, the image gets further and further and larger. Okay, so let's just revise those topics once again. If the image is at infinity, beyond C and very far away at infinity, then the image is on focus. So the object is at infinity and image is on focus. As you bring the object closer, beyond C, the image gets a little bit bigger but still smaller. And it is real and inverted. So the image can be projected on the screen. Okay. When you bring the object more closer on C, then the image is also on C. So before, if it is beyond C, it is between focus and center of curvature, like this, real and inverted. When you bring the object closer, image gets even further. And now, if the object is on center of curvature, image is also on center of curvature, and it is now larger than before, and the image is the size of object. So slowly and gradually the object size increases and it goes far away. So at infinity it is point size, then you bring closer, it becomes larger and larger. At certain point it becomes same size on center of curvature. Now you bring the object between F and C and the image goes beyond C. You bring the object on F and the image goes at infinity. When you bring the object between F and P, at that time you have gone past the point of infinity. So now you bring the object very close. At that time the image will be virtual, that is behind the mirror or inside the mirror, as you can see the image. Now this time, like the previous cases, every time the image was real and inverted, but in this case the image will be virtual and erect. Okay? Because the rays of light do not actually meet, they meet virtually behind the mirror. So that was concave mirror, all the 6 cases, just a small recap for you, okay? But this time we have convex mirror, okay? In this case, the rays of light never actually meet, okay? Because this is a diverging mirror and the rays of light are always passing away and diverging from each other. They do not meet in real time. They meet virtually, that is always behind the mirror. And that is why in this particular mirror we have only 2 cases. Okay? We have only 2 cases because unlike the concave mirror we don't have pole, focus and center of curvature in front of the mirror. So we cannot see all the different cases. In this case, F and C, that is focus point and center of curvature, are behind the mirror. Okay, and the rays of light are always diverging, they are not converging. The rays of light are always diverging and therefore they are not going to create any real image. They are always going to create virtual image. Okay, so moving on, let's try the first one, that is at infinity. So the object is at infinity. Once again, the rays of light will be parallel like this because the object is at infinity, and when you see the incident rays of light, they will reflect back like this and they will meet at focus, because we know that wherever there are parallel rays of light, they always meet at focus. So the ray of light will be like this. So in the first case, when the object is at infinity, image will be on focus. Now unlike the concave mirror, in convex mirror, the image will always be virtual and it will be erect. Virtual and erect. That means the image will not be inverted. It will be same as the object. So if the object is kept like this, the image will also be like this, but very small. Okay? Now the next case is when you bring the object in front of the mirror. When you bring the object in front of the mirror. Now you can see that in this particular case, we don't have between F and C or beyond C. So you cannot keep the object. There is always at infinity or somewhere in front of the mirror. You can either keep the object here, here or here. It doesn't matter because you don't have any specific point to determine where the object is kept. Okay. So you can say that in first case the object is at infinity, and in the second case object is somewhere in front of the mirror. Okay, it can be anywhere at any particular distance. Object will be anywhere because F and C are now virtually behind the mirror. So there are no particular points that you can define, and it doesn't matter where you keep the object. You will see in a minute. So we take 2 rays of light. First one like this, that is parallel. Okay, and we know that whenever it is parallel, it will pass through focus like this. So the first ray of light goes like this and it passes through focus. The first one we take parallel, that is after reflection it will pass through focus. Second one, let's take that it is passing through pole. Okay, so like this. Okay, and we know that it is going to create angle of incidence like this, and you can take the angle on the other side. Let's say that it is 20 degrees, so we take another 20 degrees and we make a reflected ray of light like this. So this is also 20 degrees angle of reflection. So we take the reflected ray like this and we see that they meet virtually over here somewhere, and therefore your image will be formed in this way. So you have the object over here and the image is in the same way standing upright. The only difference is that it is diminished. The object is larger and the image is smaller. So you can say that image is diminished. Okay? As we move closer and closer like this, whichever way you go, the image gets larger and larger. You will see the difference. Let's say that now we are keeping the object somewhere over here, much closer than before. But one of the rays of light is still parallel, so no need to change this one. We take another ray of light, now still passing through pole like this. Okay? And now, as you can see, the angle is larger, let's say 40 degrees. So over here as well, 40 degrees. And if you take the reflected ray, now they are meeting somewhere over here. So you can see that the previous image was over here, and now the new image is little bit closer. So as you bring the object closer, the image will also come closer. Okay? And it will become larger and larger. But no matter what, however close you bring the object, the image will always remain diminished. That means it will be smaller than the object. The size of the image will always remain smaller than the object. Even if you bring the object this much close to the mirror, the image will get larger, but it will still remain smaller than the object. Okay? So we have only two cases for this one, and the good thing is that in this particular case you don't have to remember anything. You bring the object closer and closer, image gets closer and closer to the mirror and larger, but always remain diminished, and it will not go between F and C or beyond C or beyond at infinity. Okay, so it is very simple to remember this particular mirror, convex mirror. This is a diverging mirror, and unlike before, it is very easy to understand. At infinity or somewhere in front of the mirror, the image will always remain virtual, erect and diminished. It will not go beyond F. It will always be between F and P. You bring the object closer, image gets larger and closer to the mirror. I hope it is clear to you, students. There is a table in the textbook for the concave mirror and the convex mirror, so that you can see all the images and their properties. Okay, and what are the you can say where it is placed, where the object is placed and where the image is placed. Everything is given in that table. So play my video, check the ray diagrams, and you can also check the table as well. So in order to understand all the topics. Okay. Okay, students, so we have the uses for the concave and convex mirrors respectively. The first one is concave mirrors are used in torches, searchlights and headlights of vehicle. You might have seen that in the flashlight or the torch that you use in your hand, or the huge searchlights kept in prisons or near the sea, or the headlights of vehicle. They always have something similar like this. A shiny surface is kept behind, and there is a bulb placed over here like this, and then it is covered with glass like this. The reason being that the bulb over here shines and it is kept at a focus point in such a way that the rays of light, they all goes in the forward direction like this, thus creating a powerful parallel beam of light. And that is why concave mirrors are used behind the bulbs and the flashlights in which they create a powerful parallel beam of light to look at the view in front of them for a far distance. Okay. The second one is used as shaving mirrors, because you know that in the last case of the concave mirror, when the object is between focus and pole, the object is somewhere over here, it creates a very large virtual image behind the mirror. So if a person is standing in front of a concave mirror between focus and pole, he can look at himself in a larger manner so that he can shave properly. Similarly, dentists use very small concave mirrors, okay, to keep them and see if there are any problems in the teeth, because they cannot see the back side of the teeth, right? So they use a small concave mirror on a very thin stick and they place it in your mouth and see the reflection of the tooth that is giving you the pain, so the dentist can have a very large view of that particular problem or your teeth. And that is why concave mirrors are used, because once again they create a larger and virtual image inside the mirror. Okay, only in the last case, because in all the other cases it creates real and inverted image. That means it cannot be projected inside the mirror, it can be projected on the screen as well. Okay. The other one is large concave mirrors are used to concentrate sunlight in solar furnaces. Okay, the solar furnaces are used in many places, okay, for different purposes, whether it is for boiling water or for cooking purpose, whatever purpose. But concave mirrors are used because the sun's rays of light are parallel, and when they are incident on a concave mirror, they focus it on one particular point. So all the sun's rays of light are on one single point, and that particular point gets heated up very easily, and that is why a large concave mirror is used to focus that much amount of heat and light energy on one point or one furnace, so that the food is cooked or the water is heated very nicely in such solar furnaces. So we have all of these cases for concave mirror and the uses. Now for convex mirror, those two are very simple. Used in rear view vehicles, you might have seen that in a rear view vehicle, rear view mirror of a vehicle, you will see that the vehicle behind, whether it is a truck or a large car or whatever, still you can see the whole vehicle inside a small mirror of your motorcycle or anything, because it is curved. Okay, it is a convex mirror, and we know that in convex mirror it always creates a small and a diminished image. That is why this type of mirrors are used, so that even if a larger vehicle is behind you, you can see the vehicle properly inside the mirror and give them the sight so that they can overtake or go past you. Similarly, convex mirrors are also used in shops and markets. If you know that if there is a small shop and there are many counters, so if there is a thief or a shoplifter behind that counter, then the person or the one sitting on the counter, the manager or the person who is the owner of the shop, he cannot see what is happening on that side. So what he does is he keeps the mirrors on the corners of the shop so that he can see the whole view, because it creates a small and virtual image. So everything can be seen in that mirror, the whole section. That is why this type of mirrors are very helpful in such cases. Okay, so both of these mirrors have their uses and they are used accordingly. The only thing is that you check the videos and the image formation of these mirrors once again. The video that I taught, you can see the ray diagrams in the textbook as well, and you can also check the table and match the table to the ray diagrams. You will see that in 5 cases of the concave mirror, the image is real and inverted. It goes from diminished, very diminished point size to diminished, same size, larger and very larger. Okay, I repeat once again. As you bring the object closer and closer, the object at infinity is point sized image, then it becomes larger, so it is diminished, then it becomes even larger, it is of the same size, then it becomes larger, that means enlarged image, even larger than the object itself, and finally highly enlarged when the object is at infinity. And in the last case, it is behind the mirror. So 6 cases for concave mirror, convex mirror only 2 cases, at infinity and somewhere in front of the mirror. At infinity, the image is at focus. At somewhere in front of the mirror, it is between F and P. It does not go past focus. Okay. From the next point onward, we will study the mirror formula and the sign convention for the spherical mirrors. Have a nice day.